Okay, I think it might be easier if I try and answer this question with the video. All right. So, Corey, your first question asks about the triple bonds, and you're asking me whether we're just interested in the sigma and pi bonds that occur between the two identical atoms. In that situation, we're just talking about each atom's capability of making bonds. So don't worry about the carbon and the hydrogen or the carbon and the other carbon. You're talking about one carbon as a whole. Okay, so maybe my example of ethyne will clear that up. So let's just remind ourselves, this is what ethyne looks like. Okay, and you've learned about sigma bonds and pi bonds. My sigma bonds are my covalent bonds. Okay, and in the case of carbon, they're going to be hybridized. And I'm going to just erase my, there we go. So they're hybridized in carbon. And if you remember, a pi bond is an unhybridized p orbital. So before we even attack this, carbon normally looks like this. So S and P normally looks like this in an unbonded state. Once carbon is bound to something, we put forth the theory of hybridization to explain carbon's ability to make four bonds, right? So essentially, this gets promoted. So we end up with four equivalent electrons, and each orbital is equivalent. So 1 from originally S and 3 from originally P, hence the sp3. And we know that that shape, is tetrahedral. Tetrahedral, okay. So now, these are hybridized. So that means we're talking sigma bonds. So for instance, you're talking about your methane. Okay, all these guys are sigmas because they're all single covalent bonds. All right, now let's go back to our ethyne. So for our purposes, sigma, 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 right? So I've got 3 sigma bonds in this ethyne molecule. Now between the two carbons, I've got one pi and another pi, okay? So let's talk about this carbon first. All right, so I'm gonna make him green. Okay, and it's got the one pi here, the other pi there. I'm sorry, sigma, sorry guys. One sigma, other sigma. Now, the one pi electron, and I made him green, so we'll make him green too. This pi. So for lack of this, sigma, sigma, pi, pi. So don't forget, these are my sigmas, so these are hybridized. So these are my pi's, so these are the regular p orbitals. They're not hybridized. Okay, so let's draw this carbon, shall we? All right, so in this situation, we'll treat, so this is sp, because 1s, 1p, hybrid, so the shape of that is linear. And I've got my 2 electrons in the carbon. Okay, so this is carbon right here. Then I'm going to talk about my first sigma bond with the hydrogen. So there's the overlap. There's my hydrogen. So here's hydrogen here. This is a sigma. Okay. So then I also have, and I don't know, I'll make this carbon purple. Okay. So here's my other sigma bond with my other carbon. Okay. So essentially, what have I done? I've talked about this sigma and this sigma. Now we've got to deal with the pi's. So don't forget, my pi bonds are regular p orbitals. So if you remember, and this is probably one of the last things I taught you guys, p can go as a px, py, and pz. Okay, we've already kind of dealt with the x because we're dealing with linear. So my remaining unhybridized p orbitals, we're going to draw them like py and pz. So if I take a look, I'll do the blue one here. And remember, it's going with this carbon. Okay, so we'll make this one the py, and there's one electron there, and pz, and there's one electron there. Okay, so far what have I dealt with? I've dealt with this. Now let's deal with the other side. Okay, so it's exactly the same situation. This carbon has 2 sigmas and 2 pi's. So it's going to look exactly like this. I'm not going to redraw it because I want to keep it on one page, okay? So let's remember. Here's our sigma. Okay, so that's what I just talked about. And this carbon also has its other electron here, right? So it has its 2 electrons, kind of like when we were talking about this one here before, okay? It's going to make its sigma bond with another hydrogen right there. So that's what I was talking about right here. Now we've got to deal with those 2 pi's. So same deal. Here's the 1 pi for the second carbon, this one again. Now don't forget, they can't be in the same plane because that means it would be, you'd have too many electrons in the same space. So if you take a look, this is one of your pi bonds. And then same deal here. Here we go. Okay, so if you end up looking at it, you'll see your pi bond here, and you'll see your pi bond here. Okay, and remember what I always was saying in organic chemistry, our pi bonds are our delocalized electrons. And that's why those multiple bonds had reactivity, because they were outside the plane of the covalent bond. Okay, and that's why they were reactive, because those electrons aren't stuck holding carbons and hydrogens together. Remember, I was doing my little dance, the little whooshy whooshy with my hands. Okay, so that's how that works out. So this is between the carbon and the hydrogen right here. This is between the carbon and the hydrogen, but these reflect, all the rest reflect between the 2 carbons. So you're always ever talking about the bond between 2 atoms. I hope that helps. Okay, take care. Bye, guys.